Check out this design review for a synchronous gallium nitride buck converter. First thing I notice when I click through your components is some consistent parameterization. Great job! That means it's going to be very easy to export a BOM and you won't have to manually shuffle around your columns. Now just when I think you're about to kill it with this design, what do I see? Separate ground nets. Hey, at least you connected them back together with a resistor and not with a ferrite bead. Also here in your power section, I'm noticing that you used a linear regulator to step down 48 volts to 5 volts. Be careful because that could create a lot of heat. Next, inside your PCB layout, I see here that you have a big ground cutout below this inductor. Now this is a shielded inductor, but this ground cutout isn't necessary. The reason is that your switch node capacitance is going to be much smaller than the capacitance on your driving FETs in your driving circuit. Now I know why you did this with the ground cutout and the separate grounds, and it's because the datasheet told you to do it. But guess what? We shouldn't blindly follow PCB layout recommendations from datasheets. Next, looking in 3D, I think you could tighten up this layout and reduce the board size by just rotating the inductor 90 degrees and then moving these output capacitors back towards the input. Last thing, I don't see any of the common DFA errors here except for putting this silkscreen on copper in these footprints. To fix that, you can use the silkscreen preparation tool and that'll remove that extra silkscreen, or you can just tent the vias. Other than that, great job. Want to have your design reviewed on the channel? Find me on LinkedIn and send me your design files or your manufacturing files.